Fine, boss. So you have 8 small raindrops. Radius is equal to r, which is 1 millimeter, which is falling with a terminal velocity 5 centimeter per second. Boss. Now this 8 small drops combine to be a huge drop, say of radius r, velocity, terminal velocity v. So this becomes the radius and this becomes the terminal velocity. Same thing for huge drop, right? For one huge drop, radius is r, terminal velocity is v. The question is, what will be the terminal velocity of capital V? Now, when I write, first step is to find what is r. Is that clear, boys? So step one is nothing but you have to finding the radius of the huge drop, finding capital R. Now, volume of 8 small drops. You have smaller, tiny drops. You combine all these tiny droplets, 8 droplets. If you combine them, you will get one huge drop, which means volume of 8 small drops must be equal to volume of one huge drop. Is that correct, boys? Volume of one huge drop.
Yes, ma'am.
Okay. So now what is volume? A droplet is spherical in shape. So I can write 4 by 3 pi r cube because this is a smaller drop of radius small r. That into 8 times must be equal to r cube. The volume of one huge drop. The radius of the huge drop is r. The radius of small drop is small r. So when you cancel, now what is that you're getting 8 r cube is equal to r cube. Now you take cube root on both the sides. So that becomes equal to 2r. Is that clear, boys? Correct?
Yes, ma'am.
So this is the first step. Do this. Then we'll go for the terminal velocity.
Ma'am, do we have to convert all the millimeter and centimeter to
That
meters?
will yes, boys. That we need to convert. We'll just complete this, and then while substituting, we'll find that.
All right, ma'am.
So r is the small r is the radius of the small droplet. Small v is the terminal velocity. Boys, tomorrow, ma'am will be teaching you capillary rise and excess of pressure. So I thought I have to introduce a surface tension, but I'm not able to start with surface tension. So today, just go through your textbook, read what you mean by surface tension, or uh, by your reference through net also, you can just go check what you mean by surface tension. Just have an idea so that the teacher will be finding it difficult to carry over. 11B, is that fine?
Yes, ma'am.
Okay, fine. So this is the first step. Now I have to find terminal velocity of the large drop. So let us have the general formula for the terminal velocity. Was I'm just writing the general formula for the terminal velocity, and then let me go for the terminal velocity of, or else I'll just go for terminal velocity of small drop. That is V is equal to 2 by 9 radius of the drop divided by coefficient of viscosity into rho minus sigma into G, where rho is the density of what? Rho is the density of what is sigma? What is rho? What is sigma? What is rho? Boys, what is sigma? What is rho? Rho is the density of the body which is falling through. No, can you imagine what is a medium? Yes, what is it?
No, rho is the density rate.
No, both are density. see what is happening is that the medium is air. Air is your medium, right, boys? Your water droplet is the spherical object which is falling. That is how you learnt your terminal velocity.
Droplet's density is low. And
One
sigma
second,
is the
boys.
air.
Correct, correct. So here your water droplet is considered to be the spherical body, the medium through which the body is moving, that is your air. So now the density of air is sigma. The density of the body, here the body will be your water droplet. Now the density of water droplet or water is rho. Are you clear, boys? You have to think which is the medium in which the object is falling. The medium is air. The object which is spherical body which is falling is water droplet. So rho represents the density of the object falling through a medium. Fine, boys. Same way, can you write an expression for terminal velocity of the small drop? I'll go for the terminal velocity of a large drop, right? Terminal velocity of large drop. Same formula. Then capital V is the terminal velocity of the large drop divided by 2 by 9 radius of the huge drop by eta rho minus sigma into G. So I'll mark this as equation 2, this as equation 3. Here, boys. Right? And the terminal velocity of the larger drop. So you have to find what is capital V. In that case, divide equation 3 by 2. Divide equation 3 upon 2. Kavin, divide equation 3 by 2 and get me the value of capital V. Kavin, Harish.
Yes, I'm doing it.
Surya.
Yes, ma'am.
Was divide equation 3 by 2, sorry, 3 upon 2, 3 divided by 2, get me the value of the terminal velocity of the huge drop, that is capital V. Will you be able to do this, boys? 2 by 9 will get cancelled off, rho minus sigma will get cancelled, G will get cancelled, eta gets cancelled.
Is it 20 meters per second? 20 centimeter per second.
Correct, correct. Others, Hitesh. Muhammad Nabil. Muhammad Nabil.
Yes, ma'am.
Should I do or was is that you people Samuel?
Ma'am, it's all right. Ma'am, I understood now.
Others, I'm just doing this, boys. Shall I go for the next slide? Shall I go for the next slide? Yes, ma'am. If anyone who has completed, can someone take this snapshot and put it in the chat box, boys? No, I'll do that.
No, that's fine, ma'am. I think the class is recorded, so we can see it. That's fine.
Fine. So if I'm dividing V by small v, it is 2 by 9 r squared by eta rho minus sigma divided by G divided by 2 by 9 r squared by eta rho minus sigma into G. So now what is the term which are going to get cancelled? So eta rho sigma. So V upon V becomes equal to R squared divided by. So from equation 1, what was your R? Capital R was 2 times R. Correct, boys?
Yes, ma'am.
sorry, 2 squared, I'll put r squared. Two squared r squared. So V by V is equal to 4, or capital V is equal to 4 times small v. What is the velocity of the smaller drop? What was the velocity of the smaller drop, boys?
5 centimeter per second.
5 centimeter per second. So V becomes equal to 20 centimeter per second. Well, such numericals are important, right?
Ma'am, so we can leave the final answer in
It's
centimeters.
okay, it's fine, it's fine. Otherwise, you can go for 10 to the power of -2 meter per second.
All right, ma'am.
So one I have done in terminal velocity, the other one we shall do it in coefficient of viscosity. Mohammed Danish.
Yes, ma'am.
Danish, is that fine, Danish?
Yes, ma'am.
Rishit. Shall I go for the next numerical? Shall I go for the next one?
Yes.
Yes, ma'am.
You know what is the formula for coefficient of viscosity, right, boys? Now this is a textbook numerical. Slightly you have to think over and do. Now look at the question. A metal block of area 0.10 meter square. Can you see the metal block, right? A metal block whose area is 0.10 meter square is connected to a mass of 0.01 kilo via a string which is passing over a frictionless pulley. A liquid with a film thickness of 0.3 millimeter. So which means, boys, I'm just redrawing the liquid, right, boys? Is that clear, boys? So you have a block. I'm just blowing up that. This is the liquid layer. You'll understand this. Was this layer of liquid or the film of liquid? I'm just, the film of liquid is having a thickness of what? What is the thickness of the film? So dx is equal to 0.3 millimeters. Is that clear, boys? This is your liquid. Yes. Okay, your block is on, right? There is a layer of liquid between the tabletop and the block. Yeah. Now, when the block is released, when the weight is released, the block moves to the right with a constant speed. Is that clear, boys? So when you release this object, right, your block is going to move forward with the velocity 0.085 meter per second, right? So now when the block is going to move, the film of the liquid will also be disturbed. Will not it be disturbed, boys? Do you get the picture of the question? I'll give you a few minutes. Go through the question. A metal block of area 0.10 meters square is connected to a 0.10 kilogram mass via a string that passes over an ideal pulley as shown in the figure. A liquid with film thickness of 0.30 millimeter is placed between the block and the table. When the object is released, when the mass is released, the block is going to move the right with a constant speed of 0.85 meter per second. Now, when the block is going to move, then the liquid layer will also be set in motion, which means the top layer of the liquid, I'm just using different ink, the top layer of the liquid which is in contact with the block is going to move with a velocity 0.085 meter per second, whereas the bottom surface of the liquid which is in contact with the table, right, that has a velocity 0. Can you imagine this, boys? When the block is going to move, where is the block? The block is lying on the liquid film which is on the table. When the block moves, the layer of the liquid, the topmost layer of the liquid which is in contact with the block is going to move with a velocity 0.085 meter per second, whereas the liquid which is in contact with the table is at rest. Sure? Okay, I'll put this as V2, this as V1. Is that clear? 11B, if you don't answer, what should I consider? So
Yes, ma'am.
what is the difference? Okay, what is the difference in velocity? V1 minus V2. The difference in velocity is dV, that is 0.085 meter per second.
Yes, ma'am.
Correct, boys. Now, this is only the question so far we have come across. Find the coefficient of viscosity. The formula is A into, what is that? What is the formula, boys? Eta is equal to F into A divided by dV by, what is that? dV by dx. Yes, sir. Okay. What is force? Mass into acceleration due to gravity, right? Area of the liquid film will be equal to the area of the block. Are you clear? Area of, boys, please understand, area of the liquid film will be equal to area of the block. Can you have a liquid film greater than the area of the block? It's the common sense, right, boys?
No, ma'am.
It's not common sense.
Ma'am, yes, ma'am, it is common sense.
Ma'am.
But you cannot have the area more. That's what he disagreed to.
Okay, sir. So it's wrong interpretation from my side.
Ma'am, in the question when they're saying 0.10 meter square, they're talking about the bottom area of the block, like the area below.
So whatever it is, the area of the film depends upon the area of the block which is placed on top of it. If you place a larger block, boys, the area of the film also will increase. Because if I place look at this, if I place a block which has a larger surface area, then your film surface will also, it will become thin, but still its area will widen, right? That is what. See, the area of the film is not given. Area of the block is given. So for the area of the liquid, you have to go for the area of the block. So this is what it is. I think you can do this as a homework, boys. Substitute. Go for it. Thank you, boys. You can leave.
Thank you, ma'am.
Thank you, boys.
Thank you, ma'am.
Thank you, ma'am.
Do this as a homework, boys. Do this as a homework.
Ma'am, happy
Just
holidays.
only.
Happy New Year.
Thank you, but you people will be there.
Happy holidays.
I'll call you for classes. I'll be there for the classes.
Oh, yeah.
At least 2-3 days for your vacation, because we need to complete. Otherwise, what happens is at the end we need to run through your portion. So, okay?
Understood. Thank you.
Thank you.
Happy holidays, ma'am.
Thank you, boys. Thank you. Holidays, you need to work.
Yes, ma'am. We will work.
Thank you, ma'am. Happy holidays.
Thank you. Tomorrow you have class.